Learning curve is a forecasting tool used to predict labor hours required for production. This is a little complex topic, but the good news is that in CMA Part 1 it is limited tested, so keep it simple. Learning curve measures how labor hours decline as unit of production increase because labor is learning and becoming better in their job and resulting in lesser time required to do the same task. And because of the repetition of the similar tasks, they will be doing it next time a little faster. So management uses this tool to forecast how much labor hours or labor hour cost will increase as a result of more units being produced. And the learning curve analysis is a systematic method for estimating cost when learning is present. In CMA Part 1, we have two models to study. One is a cumulative average time learning model. This model is used when we are having a mass production, when we are making identical units. And the relevant information required for management is a total average reduction in the time of all the units in a batch. The other model is incremental unit time learning model, which is suitable when we are required to have an information about every next unit would take how much time, and it is usually suitable for a job order. The cumulative average time learning model is fairly simple. It assumes that the average time per unit will decline with some constant percentage each time the quantity is doubled. This means that if I am producing one unit and it's taking me 100 minutes, the two units will not take 200 minutes. There will be a reduction in time. The formula that you will follow is that when you're taking initial time, each time the quantity doubles, a learning curve will be applied. So it's initial time multiplied by 2 times learning curve, each time the quantity doubles. To explain you this, suppose that the first 20 units take 20 hours to be produced and the learning curve rate is 90%, which means a 10% reduction in time each time the quantity doubles. So when I will be producing 40 units, it should take me 20 multiplied by 2, 2 is for the quantity being doubled, and multiplied by learning curve giving me 36 hours. It should have taken 40 hours, but there is a reduction in time due to learning curve. A 10% reduction in time will cause it to be 36 hours. Similarly, it will follow. We will have an 80 units. It will be doubled. We again multiply to 2 multiply by learning curve, and there will be reduction in time recorded. Another thing we need to see here is like since first 20 units have been produced and it have already taken 20 hours, the next 20 units are taking actually 16 hours. This is the time for successive units, the next units. I'm repeating that again. If the first 20 units have already taken 20 hours and 40 units are supposed to take 36 hours, this means that the next 20 units are taking 16 hours. An average time of first 20 hours is 20 by 20, which is 1 hour per unit. The next 20 units are taking an average time of zero point 0.8 hours, which is 16 divided by 20. So it is explained this way. The total time taken by all the units minus the time taken by the previous units, which means second lot of 20 units took 16 hours and an average time is 0.8 hours per unit. Let's put this whole let's put this understanding into a question. Aerosub Incorporation has developed a new product for spacecraft that includes the manufacturing of a complex part. The manufacturing of this part requires a high degree of technical skill. Management believes there is a good opportunity for its technical force to learn and improve as they become accustomed to the production process. The production of the first unit requires 10,000 direct labor hours. If an 80% learning curve is used and 8 units are produced, the cumulative average direct labor hours required per unit of the product will be how much? For this, first we need to find out how much cumulatively they will require the total hours. So when first unit is taking 10,000 hours, the next unit will take 16,000 hours. The fourth unit, which is when the quantity is doubling, will take to 25,600 hours, applying 2 times the learning curve percentage while it's doubling. And similarly is for 8 units, and we will get 40,960. When we have this cumulative total time, we will divide it over 8 units to get the average time. So that is 5,120. When we use incremental unit time model, now it explains the incremental time needed to produce the last unit decline by a constant percentage. But again, when the quantity doubles, which means it will tell you the first, second, fourth, eighth, 16th unit time. It cannot tell you third, seventh, fifth, 13th unit. So that means we are concerned about the last unit when the quantity doubles. This is the basic assumption we are following in CMA Part 1. However, there are algorithms and formulas available where you can find out the other units like third unit, fifth unit, sixth unit, seventh. You can find them. For this, you need a scientific calculator and logarithm charts. Neither of them are available in your CMA exam, so it will always ask you about the last unit when the quantity doubles. And the formula is to take the initial time and multiply it with the learning curve. It will give you the last unit's time when the quantity doubles. Now, for example, if the first unit takes 20 hours to produce and 90% learning curve is applied, the second unit will take 18 hours, fourth unit will take 14.58 hour, eighth unit will take 13.12, and 16th unit will take 11.81. Another thing that comes to our mind is like there is not always the similar constant percentage reduction. Learning curves get limited over time. But in CMA, we assume as if the constant percentage will be applied till we get our required result. So if you will do a question here, let's say Propeller Incorporation plans to manufacture a newly designed high technology propeller for airplanes, and Propeller forecasts that as workers gain experience, they will need less time to complete the job. Based on prior experience, Propeller estimates a 70% cumulative learning curve and has projected the following cost. The first unit is taking 20,000 average cost per unit, and the total cost is 20,000. The second is taking 14,000 average cost per unit, and that is total cost. If Propeller manufactures 8 propellers, the total manufacturing cost would be A, B, C, or D. Here we know that the time required for first unit or second unit, we will now be looking at the fourth and the eighth unit. So here what will happen is like the time that is required for the second unit, you will multiply it with 70%. It will give you the cost for it will give you cost for fourth unit, which is 9,800, and when you apply it further 70%, it will give you the cost for 8 units, which is 6,860. So the total cost for the 8 units would be then multiplying this average time on all the units. It gives you 54,880.